Okay, so in this video we're going to go over a couple of examples and finding the min and the max, and then we'll look over an example of finding the domain and range. Alright, so let's look at minimum and maximums. Right? Min slash max values. Right, the nature of the parabola shape always lends itself to one or the other, right? So it's either going to have a min or it's going to have a max. Right? Now, here, if let's say we have a parabola that looks like this, we see that at this point here, and coincidentally it's the vertex, right? So, not coincidentally, in terms of finding min or max, right, they will occur at the vertex. Right, now, since it's opening downward, we could see it reaches essentially a peak, right? And we know how to find that peak, right? Negative b over 2a, so that tells me where along the x-axis, and the actual value would be the y-coordinate, which I know how to find. And I plug in that negative b over 2a. All right, and this would be my, in this case, max value. Right, every other value would be less than that. All right, as soon as I move away from it, we'll see that it just keeps getting lower and lower than our max value. And then on the, so again, this is when a less than 0. Now if a is greater than 0, then that looks something like this, right? And we see we don't have a max value. This kind of keeps increasing, right, as we move away from the vertex in either direction, right? So it just keeps increasing, so there's no max value that it attains, right? But there is a low, right? There's a value in this case, not necessarily a peak. Okay, and again here that coordinate is found in the same manner. All right, but in this case, with a being greater than 0, we have a minimum. Okay. All right, so now let's look at an example here. Let's say that we are given the equation or the function f of x is equal to 2x squared minus 10x plus 4. All right, and I'm asked to find max slash min value. Now, one thing I notice here that this is a 2, so positive 2, so it's bigger than 0. So, oops. So it looks something like this, opening upward, so I know I have a minimum value. Okay, and I know how to find it, right? If negative b, so negative 10 is 10, 2 times a, so we get 10 over 4, which is 5/2. Okay, all right, and now, again, that is not the value, that's the x-coordinate of the value. The actual value is the value of the function, so f of 5/2. Okay, and then here we got 25 over 4. One of those values reduces. We get 25 over 2. Looks like we're going to have a denominator of 2, so I'm just going to leave this as 50 over 2. And might as well just rewrite this as 8 over 2. All right. So 25 minus 50 is negative 25. Add 8 is negative 17 over 2. All right. Doing some quick mental math here. Okay. All right, and that would be the minimum value in this case. Now, let's take a look at another example here. So let's say I have this example here. Now, first thing I want to identify, does this have a minimum or a maximum? Again, what's going to tell you that is that coefficient in front of the x squared. In this case, it's negative 1/3. So here we have a less than 0. So we have something that looks like this. Right? So we have a max value. All right, so now let's start the process of finding that max value. Okay, so we'll start by negative b, so negative 2 all over 2 times a. All right, so here we'll have, so plus, so the whole value of this would be negative, or the magnitude of it, and here we get 2 over 2/3, you get negative 3. All right. Okay, so now let's find the actual value. We'll plug in f of negative 3. 1/3 3 squared minus 2 times negative 3 plus 3. Okay, all right. And as I move my way down here, this is negative 3. It won't matter much here because when I square negative 3, I get positive 9. 9 over 3 is negative 3. Okay, and then moving on here, we get plus 6 and plus 3. So this value becomes 6. And this would be my maximum value. Okay. All right, so moving on to our last example. Here we're going to look at finding the domain and range. So for this example, so we have f of x equals to negative 3x squared plus 6x plus 9. Okay, and I want to find the domain and range. Okay, now one thing about these quadratics here, or really any power function or polynomial, the domain is the input. Now if you notice here, really we're just multiplying, adding, subtracting numbers, right? So I can do that with any value that I want, right? So what I'm getting at here is that for any quadratic function, the domain is always going to be all real numbers. Okay, because all we're doing is multiplying, adding, subtracting numbers. All right, and I can do that with any possible number, right? I can't divide by 0, but again, we're not dividing, and I don't see a division here or a fraction, so I don't have to worry about that. And in terms of what I mean is a fraction with a variable in the denominator, and I don't see that, right? And as long as I don't see that, I know the domain is all reals, right? There's no restrictions. But I am going to be restricted in my range, right? And that comes from the shape of the graph, right? So what I mean by that here is the range are the y values. And we notice here that if we have this general U shape, right, there's always a minimum or a maximum, which means that in this case we have a minimum. So there's no values that go below this value here. And again, I know what that value is, right? 2a, and again here for a bigger than 0. All right, so notice here, right, along the x, right, that value just, it goes to infinity in both directions, from going out towards negative x and positive x as well. So there's no restrictions on the input, but here there is an absolute minimum that this graph reaches, right? So recall the range is represented by the y values. So there's definitely a minimum, in this case the minimum in my interval notation would be whatever the value of the function is, in this case, and it just keeps attaining values that go up and up and up towards infinity. All right, so this will be for any quadratic function where a is bigger than 0. Now, in the other case, where a is less than 0, right, it opens downward, and we see we have an absolute max, right? Okay, now we don't have a minimum because this keeps decreasing, right, as x goes further out to the right or to the left, right? Those values keep getting more and more negative, more and more smaller. Now, in terms of the range,